You probably have heard of all sort of math and statistics being used in various branches of biology, but it's time biology gives something back to math. We start our saga with a matrix, a strictly... Okay, I have just received word that for views, we need to start with something more appealing. So, on a planet far, far away, there were sheep. The prince wished to keep records of the sheep, so he used the variable n sub I to count the number of sheep in their ith year. So n sub 1 is for the newlyborns, n sub 3 is for the older sheep between the ages 2 and 3, and so on. The values measured in the previous year are denoted by n sub I, and the values for this year are denoted by n sub I prime. If no one ever told you, well, babies come from adults. In this species, an individual might give birth and the fraction of an age group that produces babies is given by f sub I. So, we have the equation n sub 1 prime is f1 n1 plus f2 n2 plus f3 n3 and so on. And for my sanity's sake, let's just take f1 equal to 0. Unfortunately, not all sheep make it to the next year. Some choke on roses or are graphically hunted down by baobabs. The fraction that survives is denoted by s sub I. We get the equation n sub I plus 1 prime is equal to si times ni. If sheep lived up to only 4 years, then we get this set of equations. Can I now? Okay, thank you. Hey, so we can finally talk about matrices. If we write our vectors like this, then the first equation is the row of f's. And each of the survival equations take up a row like this. You may pause and multiply to make sure everything checks out. This, in population ecology, is known as a Leslie matrix. My only issue with this matrix is that it's got too many zeros in it. So let's fix that. As the planet has a very thin atmosphere, it is vulnerable to space radiation. And boy, that's not good for the sheep. This space radiation can cause the sheep population to age at different rates. So, if you were supposed to go from 6 years to being 7, then too much stress, space radiation, can age you straight up to 10. And let's say after they have hit a threshold of being k years old, they peacefully pass away in their sleep. So, sheep in n sub 5 can now come from any age group. I'll write s sub I comma j for the fraction of sheep which were counted in nj, but in the next year are counted in ni. So, we have n5 prime being this expression. n1 prime is the same as before. n2 prime is s21 times n1, n3 prime is s31 n1 plus s32 n2, and so on. All of this can now be neatly packaged into a nice matrix equation. Now to fulfill our math propaganda, let's say the radiation also makes them infertile, so no new babies are being born. This is the same as making all the fi's in the top row of the matrix equal to 0. What happens now? Well, all the remaining sheep age on, some chiseling a year at a time, fated to see their fellows grow old in front of their eyes, their wrinkled, frail bodies eventually failing them. The newborn of today will one day find itself a lone survivor, waiting for the next year to come around and turn it into dust. But yeah, we call these strictly lower triangular matrices. Triangle because of the shape the entries make, and strict because the diagonal contains only zeros. The passing of each year is the same as multiplying the matrix to itself. So, to find what happens in 5 years, we take this matrix and raise it to the power 5. In k years, as we saw, there would be no survivors left, so the matrix raised to the power k, when multiplied with the starting population vector, will give us 0. Our starting population could have been anything, and so the only way this makes sense for all starting populations is that this matrix is the 0 matrix. What we have done is shown the theorem that any strictly lower triangular matrix with k rows, when raised to the power k, gives the 0 matrix. You might point out that all the entries in our matrix are fractions, but if I give you a matrix and you factor out its largest entry, all the entries in this new matrix now are fractions, and we can apply the same logic as before. Ta-da! Just by reasoning through what happens to a population of sheep, we have just shown this theorem. And before you leave a comment, this is mostly a joke video. If you are interested in knowing about actual theorems that were inspired by biological problems, I recommend the article Can Biology Lead to New Theorems by Bernd Stumpfels. We might cover it in a future video, who knows. Anyway, thanks for tolerating this. Bye.